Okay, Claire, sorry to get this out so late for you, but I had some difficulty. I can't find my pen, so I've had to present this in a little different way. We talked about enzyme kinetics. Now we want to speak on the inhibition. And there are three main types of inhibition that you should be familiar with: competitive, uncompetitive, and non-competitive inhibition. Now each inhibition changes your normal Michaelis-Menten equation by alpha. Okay, in the case of competitive inhibition, the Km, or substrate concentration, to give you half the maximum, is affected by the inhibitor. Non-competitive inhibition affects Vmax as well as Km, and non-competitive inhibition affects Vmax and Km. So let's look at these uh, types of inhibition illustrated in the Lineweaver-Burke plot. Now you recall that we determine the Michaelis-Menten uh, behavior of enzymes by plotting a V0, initial velocity, versus substrate concentration. And if we get a hyperbolic curve, much like this one here I'm trying to draw with my mouse, where we reach saturation or maximum velocity, or approach that maximum velocity, and from this we can estimate Km, which is half the maximum velocity, and that substrate concentration that gives you that half maximum velocity. So we went through all of this, but if we take the double reciprocal plot, or we take a double reciprocal of the equation, and we can plot those values and get a line going from a hyperbolic to a linear relationship between the reciprocal of V0 and the reciprocal of substrate concentration. We want to get a line because it's easier to interpret, and we can estimate Vmax and Km more accurately if our enzyme displays Michaelis-Menten kinetics. So the slope of this line is equal to Km over Vmax. Alright, this is for the uninhibited reaction. Y is equal to, the letter Y is equal to 1 over V0. And I spoke already of Km over Vmax as a slope. A 1 over substrate concentration is our X plus B. Okay? And B is 1 over Vmax. So we have the equation for a line. The slope helps us determine Km and Vmax because we get the slope from the equation for the line. And also the y-intercept is equivalent to 1 over Vmax. So for competitive inhibition, we'll notice that our Km increases in this direction, and that increases by alpha. Alpha times Km equals Km apparent. And apparent means the apparent Km value for the inhibitor. Okay, so this would be the apparent Km. This would be the Km. The second type of inhibition is uncompetitive inhibition. Here's our equation for the line. And in this case, both our Bmax and our Km changes. The Km decreases and Bmax decreases in both cases um, in uncompetitive inhibition, and they decrease by this alpha value. And so alpha, as in the first slide, can be calculated by 1 plus concentration of inhibitor used divided by Ki. Alright, and so we can determine what Ki is by rearranging this equation such that inhibitor divided by alpha minus 1. Okay, so we can determine Ki if we know alpha and an inhibitor concentration. And so this is the nature of uncompetitive inhibition. Both Vmax and Km decrease. Lastly, non-competitive inhibition is sometimes also referred to as mixed because there's an alpha prime, put a prime on this one, and an alpha. One may affect the maximum velocity. In this case it goes down, and in the other case the Km, substrate concentration, to give us a half max, goes up. And that's not always the case. Sometimes the Km will go down, and so that's usually typical of two different inhibitors, I and I prime, or one inhibitor that may function at two different sites on the enzyme. And again, Km and Vmax are both affected by this type of inhibitor. Okay, and lastly I wanted to just remind you to understand Kcat. How do we define the catalytic constant, or the catalytic or turnover number, I should say, turnover number. That's why we take the maximum velocity, okay, Vmax, and divide into it the total amount of enzyme used in the assay. Okay, we can know the turnover, or how many substrates interact with enzyme to be converted to product. Also, catalytic efficiency. How efficient is an enzyme? This is a value that is often used for the effect of inhibitors or activators on the function of that enzyme. If we take that Kcat value and divide it by the substrate concentration, it gives you half maximum Km. This will give you the efficiency of that enzyme catalyzed reaction. Alright, and that should be it. So review this in part 1, and I'll see you in class.